So, throughout our journey in this series, we've watched identity evolve. We've gone from simple text files all the way to these massive biometric archives. But today, we're exploring the end of that lineage. We're stepping into an era that isn't defined by storage anymore, but by understanding. This is the era of the AI-native identity engine.
The next era of identity won't wait for a query. You know, that single idea is really the key to this entire shift we're about to break down. What it means is we're moving past waiting for someone to scan a fingerprint or type in a password. The whole concept of a manual search for an identity, well, it's quickly becoming obsolete.
And this is the new world we're entering. Here, identity isn't some static record you pull from a file. It's a constant, flowing calculation. You got to think of it less like a digital filing cabinet and much more like a synthetic brain, a system that doesn't just store your data, but actually begins to genuinely understand the relationships inside it.
Okay, so to really get where we're going, we first need to take a quick look back at the journey we've been on. And more importantly, why that journey is now coming to an end.
For the last 60 years, the story of identity systems was basically a story of bigger boxes, right? We went from the FBI's text-based NCIC to FAISS for fingerprints, and then to the next generation identification, or NGI, which could hold all sorts of biometrics. But every single one was just a bigger, better container. The AI-native era, it doesn't build a new container, it shatters the whole model.
And this slide right here gets to the absolute heart of that fundamental shift. On the left, you see then, data all neatly organized in rows and columns, like a spreadsheet. But on the right, now, it's a completely different way of thinking. These new systems think in what are called vectors. A vector is basically a rich numerical description, a kind of digital fingerprint of literally anything, from a face to the way you walk. So instead of a spreadsheet, the database is becoming a...
So you might be wondering, how does a machine actually learn to understand identity in this new way? Well, the entire architecture is built on one core concept, and it's called an embedding. The embedding is the absolute key to this whole system. It's all about the process of turning any unique signal, a face, a voice, a fingerprint, into a long string of numbers that captures its most essential features. It translates everything into a universal mathematical language, basically creating a single unified digital fingerprint for a person.
Now, creating this embedding takes some pretty specialized AI. As you can see in the process here, an input signal gets fed into a neural network. For images, we use things like convolutional neural networks, or CNNs, which are just brilliant at recognizing shapes and patterns. For language, we use models called transformers, which excel at understanding context. And then, these really powerful cross-modal models act like a universal translator, fusing all these different embeddings into one coherent output vector.
So what's really fascinating here is what that fusion means. The system isn't just storing a face in one place and a document in another. No, it's actively building connections. It can link a fingerprint to a face, and that face to a document, that document to a voice. Identity becomes this intricate, interconnected web of signals.
Okay, so what kind of engine can possibly power all of this? The answer is a totally new breed of database called a vector database. These things are purpose-built to navigate this complex neural space. They use these incredibly efficient indexing algorithms with names like HNSW or FAISS, and they can search through billions of these complex vectors almost instantly. It's really like having a search engine for concepts, not just for keywords.
This quote just nails the conceptual leap perfectly. Old databases search for an exact match in a field, right? Like finding a name in a list. But vector databases, they search for proximity in a geometric space. They aren't looking for a perfect match, they're looking for the nearest neighbors to whatever you're asking about. In this world, your identity actually becomes a unique point in a vast mathematical space.
This new architecture doesn't just change how we search, it completely changes when. It unlocks the ability to process identity not as some static record, but as a continuous, live stream of information.
The future isn't a lookup, it's a live identity feed. We're shifting from a world where we have to ask, who is this person, to a world where the system is just constantly aware of who is present and how they're all connected.
And the sources for this live feed are just exploding. You've got real-time video analytics pulling out faces, person re-identification networks are creating embeddings not just for a face, but for clothing and even the way someone moves. Audio models are constantly capturing voice prints. Every single signal becomes another continuous stream, feeding the vector database and updating our understanding of identity moment by moment.
And this brings us to a really fascinating new frontier: behavioral biometrics. We're not just talking about your face or your fingerprint anymore. We're talking about signals like your unique typing rhythm, your walking gait, your voice cadence. All of these can be converted into embeddings. They're unique, they are incredibly hard to fake, and they're being generated all the time. Behavior itself is now a verifiable part of identity.
Of course, a system this powerful demands a complete and total reimagining of security and privacy. I mean, the old models, they just won't work anymore.
So legacy systems focused on a pretty simple idea: encrypting data while it's just sitting in storage. But AI-native systems use far more advanced techniques. They can use encrypted embeddings, which lets you find matches without ever decrypting the raw data. They can run calculations inside secure enclaves that are completely isolated from everything else. And with federated learning, models can be trained on decentralized data without any single organization ever having to share it. So paradoxically, this means these new identity systems can become both more powerful and, potentially, much more private.
This all brings us to the final, and maybe the most complex concept of all. What happens when you combine this web of signals with a real-time stream of data? Well, you get what's called a living identity graph.
If you remember one thing, it should be this: the focus is no longer on the individual data points, the records. It's all about the connections between them.
And you can see exactly how this works here. A fingerprint is linked to a face, which is then linked to a phone. That phone is linked to a location, which is tied to an event. The system isn't just storing these facts, it's storing the relationships. And then specialized AI, things like graph neural networks, can navigate this massive web of connections, uncovering hidden patterns that no human could ever hope to spot in a simple database.
It's not a static file sitting in a cabinet anymore. It's a dynamic, constantly evolving network of relationships. It's a living graph.
So this is it. This is the final step in the evolution we've been tracking this whole time. From the simple text files of NCIC to the biometric images of FAISS and NGI, we've now arrived at a unified AI, a system that understands fingerprints, faces, voices, behavior, and context as a single, cohesive whole. Throughout this series, we've seen how the technology used to store information has always defined how we understand identity. Today, that technology has made its greatest leap yet. The question is no longer what's next, it's how we navigate the world that has already arrived.